Hey guys, what's up? This is Madan sir here, and I have another very important topic for you, and this is going to be a short one, and this is about acidity due to alpha hydrogen, right? So a bit of that I'm introducing right now, and then I will come to the topic. I told you already that alpha hydrogen is highly acidic. So what alpha hydrogen is? Let's start that. Suppose we have this kind of structure. So what we see out here, that this is your alpha carbon, this is your alpha carbon, but there you have hydrogen, and there also may be a hydrogen. So alpha hydrogen is the hydrogen which is present on the carbon next to the carbonyl group. So this is your alpha carbon here, and this hydrogen is called alpha hydrogen. So you have alpha hydrogen right over there. But in case you are thinking that this might be something as well, so there is nothing wrong, because I'm considering that this carbon has at least one alpha hydrogen. So this is your alpha hydrogen. Now alpha hydrogen is highly acidic. Something I've already told you in the yesterday lecture. Now, because it is highly acidic, so what happened? Aldol condensation reaction is carried out in presence of a base, right? And you definitely have idea that this is a basic substance, so immediately produce OH negative, right? So what happened? This hydrogen present on the alpha hydrogen, present as alpha hydrogen, is easily accessible for the movement towards the hydroxide group. And in such case, this will produce a water molecule. Now, due to that, what will happen? This carbon will receive a negative charge. So the product you have, one is water and other is a you have a lone pair and a negative charge apart from other bonds as well, right? So what that mean, that when an alpha hydrogen comes in contact with the basic substance like OH, which is very much useful, then what happens? The hydrogen shift towards the basic part of the attacking reagent, and it converts into water, while this one form a carbon ion. So this is a carbon ion. Now this undergo, you need to understand that this one undergo, this is highly stable. How it is stable? This is highly stable, and because of resonance effect, what that mean? That this carbon ion produced is highly stable because it can undergo resonance. So let me show you how this undergo resonance here. So we have R here, and then we have carbon, a double bond oxygen, and another carbon with a pair of lone pair and two of the bond itself. So what happened? This you probably do know that this has become electron rich. This carbon has become electron rich. So the polarization of electron moved towards the oxygen, and therefore this lone pair is used in formation of a pi bond. So this is what happened. R, C, single bond O. Now it has three lone pair with a negative charge, and there you have a double bond, carbon, and two of the bond. Right? So this is this molecule is highly stable because it can undergo resonance effect. And remember, because of alpha hydrogen, it undergo, because of alpha hydrogen, a compound can undergo aldol condensation reaction, and cross aldol condensation. Cross aldol condensation reaction. Condensation reaction. Now, right now, I'm not going to talk about aldol condensation and cross aldol, but I wanted to tell you what very important part is here. Just focus, what I'm trying to say. Any compound, if it has an alpha hydrogen next to the keto group, next to the carbonyl group, it can undergo, aldol and cross aldol reaction, right? But if it does not have that alpha hydrogen, it will not it will not undergo cross aldol or cross aldol condensation reaction, right? So if there is a question, suppose if there is a question that if benzaldehyde, talk about here, if benzaldehyde if benzaldehyde can undergo aldol condensation reaction, then the answer is aldol condensation. Then the answer is no. Why? Because it doesn't have alpha hydrogen. Because it does not have alpha hydrogen. Let me show you how. This is the carbon where you have the keto group, right? So this is your alpha carbon, this one is your alpha carbon, and this one doesn't have a hydrogen, right? So if this doesn't have a hydrogen, this will not undergo, aldol condensation or cross aldol condensation. Let's take you through another question. This was the first one. Let's talk about the second one. If methanol can undergo aldol or cross aldol reaction. Let's talk about. So methanol, we have, this one is the methanol here. This is the methanol. Now what you see that, cross aldol reaction will not take place because it does not have alpha hydrogen. Because it does not have alpha hydrogen, right? So now let's take another example here. Suppose if the question is like if butane 2-one, I'm taking on a random basis, any example. If butane 2-one, can undergo, then take the structure here. I'm taking it here. So butane 2-one has a structure of this one, right? Now what you see that there are alpha hydrogen. Here, right? So because it has alpha hydrogen, so it will undergo cross aldol reaction. Right? The answer is yes. Why I'm not taking through the reaction part here? Because that's going to be something very important and it has a very in-depth mechanism about. So I'll take you through that in the next lecture. Let me repeat back things I've just made you go. First thing is that alpha hydrogen is the hydrogen which is next to the keto group. The carbon, if hydrogen is placed to a carbon which is next to keto group, that hydrogen is called alpha hydrogen. Second thing, it is highly acidic. Third, it is highly reactive towards a base. And if it reacts with the base, it will convert into water, but the remaining, carbon ion will be formed, and that's also stable. Now the question is the carbon ion formed due to the alpha hydrogen donation. Why this is stable? It is due to resonance effect. What was this resonance? This lone pair will turn out to be a pi bond here, and the carbon oxygen pi bond will shift to the oxygen, right? So this is the structure you get here. You have a negative charge here and it is still stable. So this this substance is highly stable, and if it has alpha hydrogen, it will go through a number of reactions, and out of those reactions, the aldol condensation and cross aldol, these are going to be important topic. So I'll do that in the next lecture. Then I made you go through some of the important. The question was if benzaldehyde can go aldol condensation. The answer is no. Why? Because benzaldehyde does not have alpha hydrogen. This carbon does not have any hydrogen. Similarly, if methanol can undergo cross aldol or aldol condensation, the answer is no, because it does not have alpha hydrogen. Butane 2-one can go aldol condensation because it does have alpha hydrogen on both sides actually, right? So this is what the important. Now listen, this time it's not about methyl ketone. You have to remember, this is about alpha hydrogen. So you have alpha hydrogen over here, but also has alpha hydrogen over here, right? So what product going to be formed, I will tell you in the next lecture. I will say thanks for watching, and don't forget to watch the very next lecture I will do either today or tomorrow, right? And that's going to be a very important topic, aldol condensation reaction and its in-depth mechanism, right? That's it. Take